Namaste everyone and welcome back to our channel. Today, we are diving deep into one of Java's most powerful and frequently used data structures, the HashMap. You use HashMaps all the time, but have you ever wondered how they actually work internally? Understanding the internals is crucial for writing efficient and bug-free Java applications. In this 5-minute tutorial, we will unravel the mystery behind HashMap's lightning-fast performance. We will cover key concepts like hashing, buckets, collision resolution, and the vital role of hashcode and equals methods. So, grab your virtual notepads, and let's begin our journey into the heart of Java HashMap. Our first core concept is hashing and the role of hashcode and equals. Imagine a HashMap as a super efficient librarian. When you give the librarian a book, they don't search every shelf. Instead, they quickly calculate a shelf number based on the book's title. This calculation is similar to what a hash function does. In Java, every object has a hashcode method, which returns an integer. This integer helps HashMap quickly find the correct bucket or storage location for your key-value pair. But what if two different books get the same shelf number? That's where equals comes in. If two objects have the same hashcode, HashMap then uses the equals method to determine if they are truly the same object or just happened to land on the same shelf. It's a two-step verification process. Now, let's visualize how HashMap stores these key-value pairs using buckets. Internally, a HashMap uses an array, where each index of the array is called a bucket. When you put a key-value pair, the HashMap first calculates the key's hashcode. It then uses this hashcode to determine which bucket in the array the entry should go into. If multiple keys produce the same hashcode, or hash to the same bucket index, this is called a collision. To handle collisions, each bucket doesn't just hold one entry, it typically holds a linked list of entries. From Java 8 onwards, if a linked list in a bucket becomes too long, it can even be converted into a balanced tree structure, like a red-black tree, to maintain performance. This ensures that even with collisions, retrieval remains efficient. Let's see a practical example of put and get operations with a custom object. Here, we have a student class. Notice how we have correctly overridden both hashcode and equals methods. This is absolutely critical for custom objects used as keys in a HashMap. When we call studentMap.put, student1, alias, the HashMap first calls student1.hashcode to find the correct bucket. Then, if there are existing entries in that bucket, it uses student1.equals to check if student1 already exists as a key. Similarly, for studentMap.get, student2 it first calculates student2.hashcode to jump to the right bucket, and then iterates through the linked list or tree in that bucket, using student2.equals to find the matching key and retrieve its value. Without correctly overriding both, your HashMap might not work as expected. Understanding HashMap internals also means knowing common pitfalls. The most frequent mistake is overriding equals, but forgetting to override hashcode. If you do this, two objects considered equal by your equals method might produce different hashcodes, leading them to different buckets. Consequently, get will fail to find an object that you know is present. Another mistake is using mutable objects as keys. If a key's state changes after it's been put into the hash map, its hash code might change, making it impossible to retrieve later. Always ensure your keys are immutable or that their hash code and equals logic remains consistent. A poorly implemented hash code that always returns the same value, for example, will degrade your hash map into a slow linked list, defeating its purpose. Alright, we have covered a lot today. Let's quickly recap the key takeaways. Java HashMap uses hashing hash code and equals to store and retrieve key value pairs efficiently. Internally, it relies on an array of buckets, which can contain linked lists or even tree structures to handle collisions where multiple keys map to the same bucket. Remember, for custom objects, always override both hash code and equals correctly and prefer immutable objects as keys for predictable behavior. Understanding these internals empowers you to write more robust and performant Java code. Keep practicing, keep coding, and keep exploring. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe to our channel for more Java insights. Happy coding!